Hello and welcome back. We will do one final example before we look at circles again. So let's find the surface area and volume of a basketball that has a radius of 4.7 inches. And again, this is as simple as just recognizing, okay, we've got a basketball. Draw extra lines on here if we want. But essentially, a basketball is a sphere. So when we're looking at a sphere, what we need to know is the radius, which we're told is going to be 4.7 inches. And the volume of a sphere is going to be 4/3 pi r, it's not squared because volume should be measured in cubic feet, or cubic inches in this case. So this is going to be 4/3 pi r squared, and r in this instance is just 4.7. So I can plug this into our calculator, and we'll take 4 divided by 3 times pi times r, which was 4.7 cubed. And one thing to be careful of, especially when putting this into other calculators, is that we only want the 4.7 cubed. I don't want the pi or the 4/3 also being cubed. It's only r, the radius. So here we get 434 point, and let's go to the hundredths place, 0.89. We don't have to round up since the 2 is less than 5. So 434.89 inches cubed. So let's find the surface area as well. So sometimes surface area will just be abbreviated SA. And this is going to be 4 times pi times r squared. And again, we know what r is. It's going to be 4.7 squared. Just look up our formula and plug it in. So if we come back to this will be 4 times pi times r, which was 4.7 squared. The enter, we get 277.59, and I'll round there. So let's see here, 277.59, and this is going to be in inches squared. Again, area will always be in square inches, feet, meters, this sort of thing. Whereas volume is going to be in cubic inches, feet, meters squared. And yeah, so that's all there is to it. So for instance, if we wanted to paint the surface area, paint a basketball, we would need to know how much paint we'd have, how much surface area we would need to paint it. But if we wanted to know how much water we could put in a basketball, for instance, we would need to know the volume. The very last thing to look at are circles. And there are 360 degrees in a circle. So this symbol here, this little circle, means degrees. And what degrees are is they represent how far around a circle you've gone. So if you start at one point in the circle and you travel all the way around and you come right back, we would consider that going 360 degrees around the outside of a circle. So for instance, if we were to go 1/4 of the way, so from right here up to there, how many degrees have we gone? Well, 1/4 of 360, 60 degrees is going to be 90 degrees. So 90 degrees is going to be 1/4 of the way. What about if we go halfway around? So if we're here and we go halfway around the circle, just to the opposite side, well, 1/2 of 360 degrees is going to be 180. So this is quite a common joke. Quite often you'll hear about people pulling a 180, and that means that they've turned and faced the other direction. Because if we spun halfway around, we've gone halfway around a circle, we should be facing the other way. Sometimes people will confuse this, and they'll say, oh, they did a complete 360. But if you go a complete 360, that means you've gone all the way around and you're facing the same direction. So if you pull a 360, it means you're still going forward, which is a little bit amusing. So how about if I said, let's say that I want to go 300 degrees. And the question is, how far around the circle have I gone? Let's say as a fraction, how far around the circle have I gone? Well, if I've gone 300 degrees, that's 300 out of 360. So here's our fraction, and if we can reduce this, this will tell us how far around the circle we've gone. So what I'll see is that I can divide the top by 10 and the bottom by 10. It's going to be 30 times 10 and 36 times 10. 10's cancel out, and I got 30 divided by 36. Also, the top 30 is divisible by 6. The bottom is divisible by 6. So that's going to be 5 times 6. And the bottom will be 6 times 6. So we'll cancel those out. So we've gone 5/6 away around the circle. So if we're starting from here and we're going sort of up and counterclockwise, where did we get to? Well, we know that 360 is all the way back here, so it would be pretty close. And in fact, we're exactly 5/6 of the way around. So if we divide this into sixths, here's where we get to. We'll go all the way around and come back to here. So whatever distance we travel around, it'll be out of 360, which will be which in this case will be 5/6 of the way. But we can do this for any number that we want. And that concludes working with geometric equations.